Hello everyone. Today we are going to present our experiment 2, which is a single stage compressor. So this is the name of student, which is Lim Zi Hui, Muhammad Yusup bin Omar, Saefullah bin Amin, and Hafiz Izzuddin bin Jimat. Moving to the table of content, which is we have an introduction, objective, theory, working principles, experiment setup, methodology, result and discussion, safety procedures, conclusion, and lastly is references.
Okay, this is the introduction. Single stage compressor is a type of compressor which is gas or air is compressed using a single cylinder and a piston. In this experiment, single stage compressor is used to observe the change in temperature air being fed.
Itu kotak boleh cuci ya?
So for the objective, which is we want to observe on how heat is converted to work, and our scope, which is our atmospheric pressure, use is limited to 1.017 bar. Then we will record it for our temperature, which is a T2 every 1 minute interval until the temperature reach the same value for each interval minute. I recorded the speed for every 1 minute interval.
So moving to a theory and working principle, in a standard single-stage fan compressor as shown in figure 3.2.1 in the left-hand side, a fixed volume of air is trapped between two sliding vents driven by an offset rotor. This volume of air is then pushed to the outlet where the area and hence volume is reduced. Therefore, its pressure becomes higher and it is squeezed out of the outlet port. Next.
Okay, this is the experimental setup that we use in the lab. Okay, moving to the methodology. The first step is fully open the green inlet valve. Second, switch on the main power. Then record the initial readings for temperature T1, T0, T1, T2, and P0. The fourth step is this is doing simultaneously. First, switch on motor, fully open red valve, adjust spring balance on the motor until the indicator is between the line. Then record value P1, P2, flow meter, motor spring balance, and electric motor. Sixth step, use technometer to record the motor speed. After that, continue record T2 until get the similar reading. After finish, fully close the red valve. And the last one, switch off motor and main power.
So moving to a result part. So we recorded data, length of torque arm, which is 0.2 meter, compressor, which is 2.257, and then specific heat capacity of air. And then the table 3.2.1 lists all the parameters for the single stage compressor unit. Next. So this is the result that we recorded, which is the time and the temperature T2, and then the motor speed. And lastly, we calculated the energy by compressor. Next. Next. So the sample of calculations here. So we use several formulas to calculate. So first of all, we calculate the temperature in Kelvin, and then we converted the pressure into kilopascal, and then the formula we calculate specific volume through flow meter V is equals to, which we use the formula of PV and RT, and then to calculate the B, and then volumetric flow rate, we use V by using the formula. We managed to calculate the volumetric flow rate and then the mass flow rate. Then also we calculate energy added by compressor to air, which is mCp theta, and then power out of motor, which is work. Then lastly, we calculate heat release from compressor. Next. And then this is the table that we recorded the power, and then energy added by compressor, and then the heat release from compressor. Next. 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 So this is the graph 1, which is the outlet temperature over time. Next. And this is the graph 2, energy added to air by the compressor against time. Next. And then lastly, graph 3 is heat release from the compressor against time. Next. So from graph 1, the curve shows the outlet temperature. T2 increases with time. There is a sharp increase in temperature in the first few seconds. Then the temperature rises up gradually with time. The gradient of graph decreases until becomes zero at the end due to the achievement of thermal equilibrium. The growth of the temperature is due to the work input gained by the compressor during the air compression process. The work supply generates heat that is used to heat up the compressor.
Show the relationship with dah start
Yeah.
Graph 2 show the relationship between energy added to the air by the compressor and time. Based on the graph, we know that as time increase, the energy also increase with a constant mass flow rate and specific heat capacity. Since T1 is always equal to 28 degrees Celsius, therefore the magnitude T2 minus T1 increase as the heating process continues. The gradient of the curve also decreases slowly until becomes zero, and it can be concluded and the energy added to air by the compressor increase exponentially by time. Graph 3 illustrates the relationship between heat emitted by the compressor and time. According to graph, the amount heat released decreases when time increases. It is due to the increase in energy added to the air by the compressor. Hc with the formula Qc, Wm minus Hc, the rise of Hc will result in a decline of Qc when Wm is constant. Then the gradient of the graph of the curve decreases gradually until it becomes zero. From the three graphs above, the graph pattern is increased for graph 1 and 2, while decreased pattern is shown for graph 3. Thus, it can be concluded the graph 1 and 2 are showing the heating up curve, while in the graph 3, heating down curve are shown. In this experiment, the relationship between heating curve and heat transfer (QC) are determined when the heat transfer to the system of heat is gained. The molecular will gain the energy and result in the increase of internal energy of the system. In the experiment, the amount of energy lost as heat is lower as compared to the input to the compressor. On the other hand, as the energy loss is lower, so does the heat added to the air is lower. In this experiment, heat emitted from the compressor, QC, was the heat loss while the energy added to the air by compressor, HC, was the useful energy which was used to the compressor to compress the air. The work input to the compressor was from the power out of motor and it was constant throughout the experiment with the value of 816.273 watt. According to the first law of the thermodynamic, energy cannot be created or destroyed. Thus, the experiment energy input was transformed into heat emitted from the compressor and energy added to the air.
For the safety procedure, which is we need to comply when we conduct the experiment, which is we need to wear our PPE, which is lab coat, to provide protection of skin and personal clothing from incidental contact and small splashes, and to prevent the spread of contamination outside of the lab. And other than that, we want to remove a barrier in the event of an incident involving spill or splash of hazardous substances. So for the shoes or safety shoes that we need to wear uh, in the lab, which is to protect our against foot injury. Some of the most common causes include crushing, impact, and puncture.
So, for the conclusion, based on our experiments, the outlet temperature T2 gradually increase exponent as the time increase due to the heating process. As the T2 increase, energy Hc added to the air by the compressor is increased. The heat emitted from the compressor Q C decrease when the compressor outlet pressure P when the compressor outlet pressure P2 reduced by 0.5 bar, the temperature will decrease. Thus, the heat emitted from the compressor QC will decrease and the time heating may be longer. So this is our reference. So that's all from us. Thank you.